Hello everybody. In this lecture I'm gonna go through equilibrium, and equilibrium is a condition that you will have two reactions in the same rate. A forward reaction that's taking reactant to product, it has same rate as the one that is taking the product back to the reactant. Okay. So let's start with the meaning of the equilibrium first, and then we will jump to equilibrium expression, how to use that equilibrium expression, and later on you will see that I will define acidic and basic solution and try to get concentration of H plus or hydronium ion inside the solution, and then later we will define pH of those solution. Okay, so now let's go after equilibrium. Equilibrium is the state or condition that you will have two actually solid rules in it. First one, you will have two reactions. Okay, here, first reaction that is taken reactant, turn it to the product, is going to have the same rate as the one that is taking 2 mole of NO2, and it will turn it back to N2O4. Rate of 1 and 2, so I'm gonna say rate of reaction 1 is gonna be equal to rate of reaction 2. Okay, so rate for those two are equal. Okay, so first one, as you see, it says rate of forward and reverse reactions are equal. Okay, so I'm gonna put star here and there. Next thing is that we need to follow it is the concentration of reactant and product. Under equilibrium condition, concentration of reactant and product are constant. Okay, constant but not equal. Okay, constant but not equal. They can be sometimes equal, it depends on the reaction, but when we say the concentration of reactant and product are remain constant, does not mean they are equal all the time. Okay. Okay. Let's write it equilibrium reaction, and then define the K for it, equilibrium constant. So we have N2O4 gas under equilibrium with 2 mole of NO2. We show the equilibrium by double arrows. So this sign, this one means equilibrium. Okay. Now we have K that we call it equilibrium constant. Equilibrium constant, and is equal to concentration of product to the power of the coefficient, let's say M, divided by concentration of reactant, the power of, again, the coefficient of the reactant. So in this case, you have N2O4 a reactant and NO2 product. So K, it will be product, we have NO2. We have two of them. Divide by reactant N2O4. Okay. When you put a compound in between two brackets, like NO2, that means concentration. Okay. This is concentration of NO2. Okay, so always when we put the brackets, we're talking about concentration. concentration of NO2, okay? Okay, so K is equal to concentration of product to the power of, here coefficient, this is 2, divided by reactant, the power of coefficient is 1, so I can write 1. Next thing, this K was obtained by using concentrations. So we say C, Kc. Kc means K that we got it through concentration. Okay, and any concentration that we use was under equilibrium condition. Okay, so this is gonna be here. This is gonna be a concentration of NO2 under equilibrium condition. Okay, so anytime you're using K, you need to use equilibrium concentration. So I'm going to say here, this is going to be equilibrium concentration, that one equilibrium concentration, and because I use equilibrium concentrations, K, it will be Kc. Okay, so the general formula, if you have A mole from A plus B mole from B, and you get, let's say, C mole from C plus D mole from D, you go with this. Okay, you go K equal to concentration of product, we have C to the power of C multiply D to the power of D divided by A to the power of A and B to the power of B. If K way bigger than 1, meaning that we have more product, mathematically this number, it will be bigger, K, it will be bigger, big number when the denominator really small one. Okay, the denominator is small number. Okay, so we have huge amount of C and D. That means here K way bigger than 1 means more product and less from reactant. If K smaller than 1, meaning we have mainly reactant and not much from product. Okay. So this is the way we get K and meaning of K. Okay, so let's try to use K for different reactions. Okay. So I showed you how to get the K for N2O4 to 2 mole of NO2. Okay, next thing. What if we have a reaction that one side of it, or at least in one of them, we have solid, then other side we have, say, solution. Say you have silver nitrate, silver nitrate, and you add to it sodium iodide. Sodium iodide. You might get this. Okay. Might get, let's say you got silver iodide, solid, plus, next one, sodium nitrate. Say you have such equilibrium. Okay, you have such equilibrium and you want to write the K for it. K for this reaction, okay, if there is such equilibrium, is going to be equal to product to the power of M over reactant. Product, I have what? I have AgI, okay, is solid. Okay. Multiply NO3, sodium nitrate, divide by AgNO3 multiply sodium iodide. Okay. Here, one of our product is solid, and because it's solid, we're not gonna write it inside the equilibrium, inside the equilibrium formula, because this one says solid, so it's out of the liquid phase. Okay, it's sitting at the bottom of the flask or container. So do not write any formula, any compound that comes with S or solid state inside the equilibrium expression. So I'm not gonna write this one. Simply, I will erase it. Okay, simply I will erase this one. And I'm gonna say I can't have it here, and Kc is gonna be equal to sodium nitrate divided by AgNO3 multiply sodium iodide. Okay. So first rule. Okay. First thing, do not write any compound that it has solid state inside the equilibrium expression. Okay, do not write it. Why we're not writing it? Reality, okay, here, when we have solid, whether it's a reactant or a product, we say the change with concentration of solid is not much. Okay, it's not much. Why? Because solids are so packed in a tiny volume, we can have plenty from, a number of moles. So usually we ignore, solid. Okay, another example. We have calcium carbonate, solid under equilibrium with calcium oxide, solid, plus CO2 gas. Okay. K is going to be equal to any compound that it has, it has S or solid, you will ignore it and you're not going to write it. So Kc in this case is going to be product power of M over reactant. Product, I have only CO2 in just one. How about the reactant? Okay, this one is solid for the product, that one also solid, so I'm not going to write them. So I get only CO2. So Kc for this reaction is going to be equal to concentration of CO2 under equilibrium condition. Do not write any compound that has solid state inside K formula. Okay, so any compound that it says solid, ignore it. Okay, this is first thing, first one, or first, like a note that you need to keep it in your mind. The second one is going to be when you're dealing with liquid. Okay, so first one, if you have S. The second one, if you have L. L means pure liquid. Okay, so L, when you see a compound that it has L, that means pure liquid. For example, let's say we have this HCl aqueous plus H2O liquid under equilibrium. Should not actually use HCl. I go with HCN, sorry. HCN. Not HCl, HCN. And under equilibrium with H3O plus aqueous plus CN aqueous. Any compound that it has S or L state, ignore it. K, C is going to be equal to product over reactant. The concentration of product over reactant. Product, we have hydronium. Just 1 mole, so I say 1. Next, we have Cn minus, and just 1. Divide by HCN, only 1. And this one is the H2O. We will ignore it. Okay, we will ignore H2O. Okay. Again, why we are ignoring H2O? Because it has L state. Okay. Again, what's the real, science or reason behind it? When you have a compound that it says L or S, we say the concentration of that liquid, pure liquid, is so high that whatever you use to react with the HCN, when you compare it with the initial concentration of H2O, is nothing. Okay, is nothing. So for example, if you go with 1 liter of H2O, it has concentration of H2O for 1 liter is around, I think is around 55 to 56 molar. Okay. And say, like, I don't know, 1, 2, 3, 4, those, if you use 3 or 4 molar for a compound as a solution, as a concentration, I'm going to say you are dealing with a high concentration. Yeah, 1 or 2, we call them high concentration. So let's say you have 1 mole or 2 molar, and you react with one that it says 55 or 56. Whatever you're going to lose to react with the HCN is nothing. If I subtract 1 or 2 from 56, it's not going to change the story. It's 54. So what? Is it a huge change with the concentration? Not really. And because it's not much, we will ignore any compound that comes with S or L as a state of compound. So from now, anytime you have S or L, simply ignore it. Okay, simply ignore it and do not write it inside the formula. Okay. Next thing is, we said we have N2O4 gas under equilibrium with 2 mole of NO2 gas. Because it says double arrow, so we are dealing with equilibrium. We say product over reactant. Product, you have 2 mole, reactant 1 mole. Okay. What's the product? In this case, I have NO2, 2 of them, over reactant N2O4, just 1. Okay. Maybe I should use, M and N as a general formula. Okay. M and N. Okay. M is the coefficient of NO2 and coefficient of N2O4. Okay. I'm using equilibrium concentrations, but check the state of those two compounds. Both of them are gases. Because they are gases, we should be able to use their pressures to define K. Okay, so I'm going to say, because I'm dealing with gases, I go with Kp. I'm going to use the pressures. Pressure of product. So you say pressure of, this is not product. Pressure of product, NO2. How many do we have? We have 2 of them. Divide by pressure of N2O4. I have only 1. So now what I got Kp, equilibrium expression for pressures, equal to pressure of NO2 to the second divided by pressure of N2O4 first order. Okay. Now Kc stands for equilibrium constant or equilibrium expression when you are using concentration. This one is not equal to Kp. Okay, at least in most cases. Okay, in most cases they are not equal. So that means sometimes they can be equal, and I'm gonna follow that one. I'm gonna see, when they will be equal, and what's the connection between Kp and Kc. Okay. For reaction like N2O4, here N2O4 gas, you go with 1 mole under equilibrium, product 2 mole of NO2 gas. Okay. I can define Kp and Kc for them again like the one I did it before, but I will write a formula first and then I will show you the connection of Kp and Kc for this reaction. If you have A mole from A and you add it to B mole from B and under equilibrium with C mole from C plus D mole from D, okay, we say Kp is gonna be equal to Kc multiply a correction. Correction is gonna be RT to the power of delta T. So this is gonna be correction. Okay, correction, to transfer concentration to pressure. Okay, now what's the R? R is gas constant. T is temp in Kelvin, temperature in Kelvin, and R is atmosphere to liter mole to Kelvin. How about delta N? Delta N is number of mole for a product in a gas phase minus number of mole of reactant in a gas phase. So delta N is solid only and only for gases, reactant and product. Okay, gases, reactant and product. If you have liquid or say solid, just simply ignore them. Okay, ignore them. So delta N for this reaction is going to be number of mole of product. You look to the product, you have 2 mole from NO2. So you say number of mole of product has to be gas minus number of mole of reactant has to be gas. Product, I have 2 mole. Reactant, I have only 1. So delta N, it will be equal 1. Okay, delta N is going to be equal 1. So now go with this one. Kp equal to Kc multiply RT to the power of delta N, you got it 1. So Kp will be equal to Kc multiply RT. Okay. Now you can find, the connection between Kc and Kp. Okay. I'll try to open this formula more and try to, use like one question and practice one question about it, make it more clear. Okay. Here is a question. We have equilibrium. Says gas, 2 mole gas, we turn it to 2 mole of NO plus 1 mole Cl2. All of them are gases. They gave you, the Kp, and also we have the partial pressure of NoCl and Cl2 as well. And they are asking, what's the partial pressure of NO? So we go with this. Kp is going to be pressure of product. Product, we have NO. We have 2 mole of them. Pressure of Cl2, we have only 1. Divide by pressure of NoCl, and we have 2 of them. We are looking for pressure of NO. Pressure of NO will be equal to Kp multiply P multiply, okay, say P of NoCl to the second, divide by pressure of Cl2. And this one to the first. Okay. If you're looking for pressure of NO, then you have to get the second root of it. So it will be pressure of NO is going to be second root of Kp multiply P NoCl to the second, divide by PCl2 first. Hold this one. Okay. Hold this one under the second root. Okay. Let's put the number. Let's put the number and get NO, P of NO. So we go with P of NO. Kp, we have it. Okay. We have Kp is equal to 1.9 multiply 10 to the power of minus 2 multiply pressure of NoCl. NoCl pressure for it, where was it? We have it 0.33 to the second, divide by pressure of Cl2, we have it 0.5 or 50. Okay. And we need to get the second root from it. That's gonna give us pressure of NO. So let's go with 0.30. Okay. 0.33 to the second. And multiply 1.9 minus 2. Divide by 0.5. Okay. Got it. 0.064. Let's double check it. Yeah, 0.064. Okay. So pressure of NO is 0.064 atmosphere. Okay, because I use atmosphere for P of NaCl and Cl2 as well. We will get atmosphere. Okay, one thing that you need to know: K, their Kp and Kc do not have unit. Okay, none of them has a unit. Okay, so we got the partial pressure of NO. Next thing is they are saying, hey, why don't you find Kc? Okay, we said Kp is equal to Kc multiply RT to the power of delta N. T is, what's the T? 25 degrees Celsius, which is 298 Kelvin. And R, 0.08206. Okay. Next, so we need to calculate delta N. What's the delta N? Number of mole for product in a gas phase minus number of mole of reactant in gas phase. Okay. Please look to this reaction. We have 2 mole product plus 1 mole of Cl2. So I'm going to say 2 plus 1 for the product minus 2 for the reactant. And that's going to give us plus 1. Okay. So Kc is going to be Kp divided by RT to the power of delta N. Kp, we have it 1.9 multiplied 10 to the power of minus 2. R, we have it 0.08206 multiplied the temperature 298. Okay, and delta N, we got it 1. Okay, and have 1.9 to the power of minus 2 divided by, give me 7.77 multiply 10 to the power of minus 4. Let's double check it. Okay, so it says 7.26 fig here 8 multiply 10 to the power of minus 4. So as you see, Kp is not equal to Kc. Okay, so this one was the first example about using this formula, Kp equal to Kc multiply RT to the power of delta N. And next one, let me check something. Here's the second example. Okay, so we have NH4 HS solid under equilibrium with NH4 gas, NH3 gas, and then secondary product is H2S. Again, gas. They are saying if partial pressure of gas is 0.265, find Kp and Kc. Let's define Kc first and then Kp. Kc is equal to product power of M over reactant to power of N. Okay. ignore any compound that it has a state of solid. Okay. Product, I have NH3, so I'm going to say concentration of NH3 under equilibrium. I have only one. Second one is going to be H2S, equilibrium condition, and only 1 mole. Reactant, this one is solid. Because it's solid, I will ignore it. So this is the Kc. How about Kp? Kp, you go with compound that they have state of gas. So you go pressure of NH3 multiply pressure of H2S, and I have 1 from each. Again, this is reactant and it's solid. We don't care about it, and it's not gas. Okay, because it's not gas, you cannot use it inside this formula. Okay, so when you are writing Kp, you will write any formula, any compound that it has a state of gas, not liquid. Okay, because this is a Kp, it's different than Kc. Kc, we will write the the solutions. Okay, mixture or solution, we will write them, but not when it comes to Kp. Kp, because it says gas, you have to look to pressure of the gases. Okay, I have partial pressure of the gases, so I can put it inside this formula. I'm going to call this one 1, this is 2. If I put 0.265, I can calculate Kp. Kp is going to be pressure of, it says each gas, you go with 0.265 multiply 0.265, and that's going to give you the Kp. Answer is 0.0702. This is the Kp. Okay, so you have the Kp. Now use the temperature. Temperature is given, and Kp plus R, and calculate the Kc. So I'm going to say Kp is equal to Kc multiply RT to the power of delta N. T is 295 Kelvin actually in this case. And R, you go with 0.08206. How about delta N? It will be number of mole of product in a gas phase minus number of mole of reactant in a gas phase. So delta N, product, we have 2 gases. So I go 1 plus 1. Coefficient for each one is 1. How about reactant? Reactant, this is solid. Because it's solid, we say 0. Don't write 1. Please be careful about this one. This is not going to be minus 1. Don't say a coefficient here is 1, so I'm going to say 1. No, this is solid. Because it's solid, you can write it inside the delta N. So it will be plus 2. Okay. We're looking for Kc. Kc is going to be Kp divided by RT to the power of delta N. Kp, we got it from first part is 0.0702 divided by RT. And delta N, this time we got it 2. So Kc, 2 will be equal to, okay. Okay. And 0.0702 divided by 1.19 or 1.20 actually. The power of multiply 10 to the power of minus 4, so let's double check it. Okay, 0.0702 divided by 26 multiplied 295. 2. Okay, yes. So I got the same number and it's equal to 1.36 fig, so it's gonna be 20 multiplied 10 to the power of minus 4. Okay, so we practice at least 2 examples about using Kp and Kc. Now slowly I'm gonna switch to acidic solutions, and I'm gonna use K formula for acidic or basic solution, and try to define something that we call it the pH of the solution. You want to know how much acidic is the solution. Okay. First of all, we want to know what's the meaning of acid or base. Okay. Okay. We have at least three definitions for acid. Acid is a compound that when you dissolve it in an aqueous solution, it will produce H plus or hydronium ion. Okay, H plus or hydronium ion. Okay. So HCl, if I dissolve it in an aqueous solution, this is aqueous solution, it will give me H plus ion and an ion. Because generated H plus, we call it acid. HCl was dissolved in aqueous solution. So you have the right to say HCl react with H2O, and this is liquid, and generated H3O plus, we call it hydronium and Cl. Okay, hydronium and Cl ion. Okay. Which one should I write? The first formula or the second when I'm defining acid or bases? It doesn't matter really. It doesn't matter. Okay. When you say aqueous, okay, or when you put aqueous for as a state of any compound, then we know that your solvent is water, okay, or you dissolve it in water. So there is not much point really to write H2O. In chemistry, usually, we write aqueous when we ignore the H2O, because we know that like by writing aqueous, we already mentioned that the solvent is H2O. Okay. How about the base? Base is a compound that when you dissolve it, it will generate hydronium ion. Hydroxide ion. Hydroxide ion. So sodium hydroxide, if you dissolve it, it will release or generate OH or hydroxide ion. And because we got hydroxide ion, we call sodium hydroxide base. And this solution, the one we generated, is basic. First one here for HCl was acid. Solution now is going to be acidic. So based on Arrhenius' definition, acid is a compound that's going to release H plus or hydronium ion, and base it will generate OH or hydroxide ion. H2O liquid under equilibrium with H plus and OH. So we have an equilibrium for H2O. This is H2O liquid. This is the reactant under equilibrium with H plus and OH. Let's write the K for it. Kc is going to be equal to product H plus multiply OH divide by H2O, but H2O is liquid. Because it's a liquid, we're not going to write it. Okay, we're not going to write that one because it's liquid. Be careful. We call this one, we call this Kc for water, we call it Kw, equilibrium expression of water or dissociation of water, and is equal to H plus multiply OH. Kw, or any equilibrium constant, is subject to temperature. Okay, subject to temperature. Okay. And T equal to 25 degrees Celsius, Kw is equal to 1.00 multiply 10 to the power of minus 14. So Kw equal to 1.00 multiply 10 to the power of minus 14, and is equal to concentration of hydronium or H plus multiply concentration of OH. If you have any of this, you can calculate, you can calculate the second. So give me H plus or OH, I can calculate the second for you. Okay. So I know the Kw of water, meaning of the Kw, and also the number of Kw. Now I will define two terms, pH and pOH. pH is equal to minus log of concentration of H. Okay. P stands for potential and is equal to minus log. Okay, minus log. So when you say Px means minus log of concentration of X. So pH is going to be equal to minus log of concentration of H plus under equilibrium condition. pOH is going to be equal to minus log of OH under equilibrium condition. pH plus pOH equal to 14.00. Okay, 14.00. Now, if H is concentration of H is equal to OH, in that case, we say pH of the solution is equal to 7, and the solution is neutral. Okay, solution is neutral. And what's the concentration for H here? Concentration of H is going to be equal to 1.00 multiply 10 to the power of minus 7. Okay. So this is the first one. Second, H, concentration of H bigger than OH. In that case, concentration of H is bigger than 1.00 multiply 10 to the power of minus 7. pH of the solution is less than 7 and is acidic. Third one, if H, concentration of H, smaller than OH, that means concentration of H plus is less than 1.00 multiply 10 to the power of minus 7. In that case, we say pH of the solution is bigger than 7, and we are dealing with basic solution. So I'm gonna now put all these 3 points in one graph. Go here. pH, go 1, pH, since this one is going to be 7, pH 14. pH 7 is going to be the neutral area. In pH 7, we have concentration of H equal to OH. And concentration of H, which is equal to OH, and is equal to 1.00 multiplied 10 to the power minus 7. Okay. Acidic condition, this one is going to be acidic. pH is less than 7. When the pH is bigger than 7, we call it basic. pH less than 7 is acidic. That means you have more from H+. When pH is bigger than 7, you have OH more than H+. For acidic area, concentration of H+ bigger than 1.00 multiplied 10 to the power of minus 7. And for basic, concentration of H+ smaller than 1.00 multiplied 10 to the power of minus 7. Okay. Let's practice a couple of questions about solutions. First one says, what's the concentration of OH if concentration of HCl is equal to 1.3 molar? Okay. So we have HCl aqueous plus H2O. We get hydronium ion plus chloride, or you have HCl aqueous, you get H+ and chloride. I want you to be sensitive to number of errors that I wrote this time. I wrote only one. If it's just one error, that means strong, either acid or base. Depends to the starting compound. I'm dealing with acid, so this is gonna be strong acid. Okay. Why? Because I showed you only one single error and I did not give you K. Okay, I did not write any K. So from now, anytime you are given a compound and you want to know whether it's a strong or a strong acid, or strong base, or weak acid or weak base, you need to look to the given reaction. If this shows only single error, that means it's either a strong acid or a strong base. If you were not given a K for it, again, that's either a strong acid or a strong base. Okay. So the question is says we have HCl aqueous is releasing H and Cl minus. Okay. You write this reaction. Okay, you write the reaction, and now I'm going to show you something that we call it ice table. Okay, and ice table stands for initial concentration, and then change, and then end. Okay. Initial concentration of HCl, it says 1.3 molar. Okay. At the beginning, how much from H plus do we have? Nothing at the beginning. How about chloride? Nothing. And then I say change. Something will happen. You added HCl, you mix it, you're gonna lose something from it. How much? You look to the arrow. If it's a single arrow, that means strong, and it's gonna be 100% conversion. Okay, 100% conversion. Whatever written here, you write it again, and you subtract this number from it. So you subtract it from itself, and that means it's gonna be 0. Okay, or just simply, say, okay, if you don't want to write this one, actually, I should not write it that way. Let's say minus. Okay, just go with this one. So simply just say minus itself. Minus itself. How about this? It's going to be plus one time of this number, 1.3. And I'm writing plus. Why plus? Because I'm generating it. How about chloride? It's 1. So I'm going to say plus 1 time of 1.3. And here we said minus 1 time of 1.3. Okay, so you can say 1 time of 1.3. And then you go at the end. Okay, you will reach 1.3 minus 1.3, 0. 0 plus 1.3 is 1.3, and 0 plus 1.3, 1.3. Okay, what's this number? This is concentration of H plus under equilibrium condition, and this is concentration of chloride under equilibrium condition. The question is saying Kw is equal to H plus multiply OH. Okay, and they are asking find concentration of OH. So concentration of OH, it will be Kw divided by concentration of H plus 1.00 multiply 10 to the power of minus 14 divided by H. Okay. H, we have it 1.3. And the answer is going to be, so we have minus 14 divided by 1.3, and is 7. It's 1.326 feet, so here by 69 26 feet multiply 10 to the power of minus 15. Okay, so that's going to be concentration of OH. We call this table, we call it ice table. And I'm going to show you now more from istable. We will practice plenty times of the istable, and you will see that it's really helpful and it's easy, actually it's easy to build the istable for any chemical reaction. Okay. I want to, I want to practice more question about pH or POH, but before I do that one, I want to, show you how to write the right sig fig when it comes to log. You want to get here log of 3.2, and I get the answer for it. Okay, 3.2, and or say what else? Okay, can go with which is going to be equal to 5.4 multiplied 10 to the power of minus 5. Okay, I want to get log of 5.4 multiplied 10 to the power of minus 5. Okay, I will do this one first. Log of 5.4 to the power of minus 5. Okay, I did not click an equal sign. Okay, I did not, or enter, I did not hit the enter, but I can tell you the answer is going to be 4 point something. Okay, 4 point something, and here the answer is 4.267.6. Now I want to write the right sig fig for it. Okay, right sig fig for it. You have 2 sig fig here. You need to put 2 digits after decimal point, and then it will be correct. So it's going to be 4.26. So the correct answer is going to be minus 4.27. This is the correct answer. But how did I, how did I figure that the answer is going to be 4 point something? Okay, 4 is not a sig fig file, sig fig, number. 4 stands for number of zeros before first non-zero. Okay, we have 4 zeros, 1, 2, 3, 4. So this 4 stands for 4 zeros. And then we get the 5, which is non-zero. Okay. So 4 is not significant. I have 1, 2 sig fig. Because I have 2 sig fig, I need to write 2 digits after decimal point. So for this number, I have 2 sig fig. Whatever I get, I need to write it with 2 digits after decimal point. So it's going to be log of 3.2. The answer is 0.505. I need to write it 2 sig fig. Here 2 sig fig. It will be 0.51. Okay, 0.51, and that's the correct answer for it. Okay. Let's practice more. We have this number, and also we have we want to get the log from them. So I'm gonna say here again, log of 3.60 multiply 10 to the power of 4. This one, it has 3 sig fig, and that one 2 sig fig. So first one, we need to have 2 digits after decimal point. So log of 6.9 to the power of minus 7 is going to be 6 something, and is minus 6 is minus 6 dot, we need to have 2 digits after decimal point because we have 2 sig fig, so it's going to be 16. Remember, you need to have 2 digits after decimal point. How about this? Log of 3.60 power of 4. It will be 4.556 is the correct answer for it. Okay, have 3 sig fig. I need to have 3 digits after decimal point. 4 stand for, number of zeros. Okay, 4 stand for number of zeros. Okay, so this number you can write it as 3. That one you can write it as we had 6 zeros. Actually, yeah, 6 zeros. 6 zeros before we hit the first non-zero, which is 6. And so that 6 stands for 6 zeros. Okay. And so now that we know how to write the right sig fig when we are dealing with log, I'm going to practice some question about it. We have a pH that's equal to 4.82. And we know pH is equal to minus log of concentration of H. So minus log of concentration of H plus is going to be equal to 4.82. Log of any number, like say X equal to B, concentration of X is gonna be, base here is 10 to the power of B. So for this, you go log of H equal to minus 4.82. So concentration of H or X equal to, base is 10 to the power of minus 4.82. So it's power of minus 4.82. The answer is 1.5 multiply 10 to the power of minus 5. Okay. I wrote the number with only 2 sig fig, but the first number that you had was 4.82. Okay. Question is, why didn't I write the number in 3 sig fig? 4 stand for number of zeros, not a significant figure. If you open this number, it's going to be here 0.00015. We have 4 zeros, okay, 4 0, and then you start with non-zero. Okay, so the first non-zero number, which is 1, comes after 4 zeros, and this 4 stands for those zeros. So 4 is not significant because any zero on the left side of first non-zero, we ignore it. We don't care about it. Remember when we were at the beginning of the semester, we said any zeros on the left side of non-zero, we toss them. So I'm going to toss them. Underline first non-zero is 1. You say 1, 2 sig fig. Because we have 2 sig fig, I need to write the number with 2 sig fig. So here, I look to 8 and 2. 8 and 2 will tell you number of significant figures. Because we have 1, 2, so you need to write your number in 2 sig fig. Next question. It says we have a blood sample. Okay, concentration of OH is given is 2.5 multiplied 10 to the power of minus 5. And they're asking what's the pH. There you go. Here. You have 2 ways to do it. You can go pH plus POH equal to 14. So pH is going to be 14 minus POH. Define the POH. POH minus log of OH. So it will be minus log of 2.5 multiply 10 to the power of minus 7. And this is going to be 6.2 digits after decimal point. So minus log of 2.5 to the power of minus 7 is 6.60. I have 2 sig fig and it has 2 digits. So pH will be 14 minus POH, which is 6.60. That's going to be 7.40. This is one way to do it. Okay. Or, okay, you can go with this. KW is equal to H plus multiply OH. So OH, or my bad, H plus is going to be KW divided by OH. KW is 1.00 multiplied 10 to the power of minus 14 divided by OH, which is 2.5 multiplied 10 to the power of minus 7. That's going to be 4.0 multiplied 10 to the power of minus 8. So pH is going to be equal to minus log of H plus and minus log of 4.0 multiplied 10 to the power of minus 8. And that's going to be 7.2 digit after decimal point. It's 7.40. It's 7.3979. If you round it to 2 digit after decimal point, it's going to be this number. Okay. I think I'm going to stop the lecture here. I hope this lecture was useful. Have a wonderful time, guys. Take care.